Hello.
Hello, sir.
Yeah. We'll continue with complex numbers. So first problem is let theta 1, theta 2 till theta 10 be positive valued angles in radian such that theta 1 plus theta 2 adding all the way up to theta 10 is equal to 2 pi. Define z1 is equal to e power I theta 1, zk is equal to zk minus 1 into e power I theta k for k goes from 2, 3 till 10. Statement P is saying mod of z2 minus z1 plus mod of z3 minus z2 and so on till mod of z10 minus z9 plus mod of z1 minus z10 is less than equal to 2 pi, and statement Q is saying mod of z2 square minus z1 square plus z3 square minus z2 square so on till z10 square minus z9 square plus z1 square minus z10 square is less than equal to 4 pi. We have to select which options are right, like P is true, Q is false, and D option is P is false, Q is true, C is both true, and D is both false. Okay, try it out. Have you understood what Z1, Z2 and all mean?
Yes.
Okay. What is special about these 10 complex numbers?
Sir, they are- one second.
Z1 is this, Z2 is this, right?
Yes, sir.
If you do Z3, it will come out as e power I.
Plus theta 2 plus theta 3.
Hmm.
Yeah. So,
Similarly, till Z10, it will come like that, right?
yes, sir.
So what is special about them?
Sir, they all lie on a circle of radius 1.
Right. And the angles between them, if Z1 was starting from EI theta 1 here, this is theta 1, Z2, this much angle is theta 2, right?
Yes, sir.
And when you go till Z10, Z10 comes up to here, I think.
Hmm.
Because 2 pi will be coming back to here, right?
Yes, sir.
So, so they all lie on a circle of radius 1 and they are the vertices of a de- decagon, right?
Decagon. Yes, sir.
But we don't know whether it's a regular decagon or not, correct?
Right. Yes, sir.
Because they didn't say whether theta 1 was equal to theta 2 or not,
Hmm.
correct?
Yes, sir.
So they are the vertices of a decagon, but it's not necessarily regular,
Yes, sir.
correct?
Right.
So what is the meaning of each of these absolute values?
Sir, sir, the distance between two points of the decagon, basically.
So those are the side lengths, right?
Yes, sir.
So length of the sides of the decagon, basically the circumference of the decagon.
Right.
That is adding up all the sides basically.
Yeah, and it will be less than 2 pi because it's not going to be able to completely cover the circumference of the circle. So,
So circumference of the circle is going to be 2 pi. So it is obviously less than that. So B statement
yes,
is correct.
yes,
Now similarly, you have to think about what happened in this statement. You
yeah.
should start by analyzing what is the complex number z1 square and z2 square and then think about what is going on. Z1 square is this, Z2 square is this.
Yes, sir.
Now the angles are doubled, right, between them.
Yeah.
These are also points on the same circle, but they are at double the positions of theta 1 and theta 2 and all, right?
Yes, sir.
So if you think about it, earlier, let's say Z1 was here and Z2 was here. This angle was theta 1 and this angle was theta 2. Z1 square would be at 2 theta 1 position, right?
Yes, sir.
And Z2 square would be at 2
Two,
theta 2 position.
two theta one plus two theta theta.
Right.
Yeah.
This much is 2 theta 1.
Yes.
And so, yeah, so Z2 will be even further away. The difference of angles between Z1 square and Z2 square will be 2 theta 2.
Theta.
Right.
Yeah.
So technically, uh, they are also points on the same circle, but now if you go up to Z10 square, there will be like it will come back around, right?
Hmm.
You have to do two full rotations to get to Z10 square,
Yes, sir. Right.
correct? And then you are being asked distance between these,
Huh. Right.
some of the distances between them. So one thing we could do is think of what is zk minus 1 square minus zk square mod. That is one of the terms, right?
Yeah.
In the summation.
Yes.
So we can say the zk square will be zk minus 1 square e power I uh, theta k square, right?
Two theta k basically.
Uh, and this is like this, correct?
Yeah.
So mod of zk minus 1 square can be taken common and it is 1 minus e power I 2 theta k.
Hmm.
And this mod is 1 because we know that the point lies on the circle.
Circle. Yes, sir.
So we just have to calculate mod of this. So let's do that. 1 minus cos 2 theta k minus I sine 2 theta k. 1 minus cos 2 theta k is 2 sine square theta k minus 2I sine theta k cos theta k. Correct?
Yes, sir.
Take common, you'll get 2 sine theta k common and you have sine theta k minus I cos theta k. This mod is clearly 1, right?
Yes, sir.
So the modulus here is this much.
Hmm.
We know that this is equal to mod of 2 sine theta k,
Right.
correct?
Yes, sir.
We have to do the sum of all of these mods. So, and find an inequality on that.
Yes, sir.
Okay. So, for sure, we know 2 sine theta k modulus is equal to 2 times mod of sine theta k, which will be clearly less than equal to 2 mod of theta k,
Yes, sir.
because sine theta by theta is always less than equal to 1,
Right.
correct?
Yes, sir.
So because of this, we can now replace it as an inequality and say the whole summation here will be less than equal to 2 times the summation of mod theta k, right?
Right.
And this summation was 2 pi.
Yes, sir.
So less than equal to 4 pi.
Yeah.
So here in this question, you can visualize it, but visualizing it doesn't give us the solution very easily here. The previous part, it was giving us the solution.
Yes, sir.
So you should probably evaluate one term and try to get the general meaning of that and then think of what we can do.
Yes.
Correct? Okay. Uh, Fine. Let's go to the next problem. Real Z denotes the real part of Z. Let S be the set of all complex numbers satisfying Z power 4 minus mod of Z power 4 is equal to 4iz square. Then the minimum possible value of mod of z1 minus z2 square, where z1 z2 belongs to S with real part of z1 greater than 0 and real part of z2 is less than 0, is what?
So is it 8?
1 second. Okay, that is correct. Uh, Fine. So that was easy only. Let's go to the next one. S is the set of all complex numbers Z satisfying mod of Z square plus Z plus 1 is equal to 1. Then which statement is true? Statement is true mod of z plus half is less than equal to half for all z belongs to S. Mod of z is less than equal to 2 for all z belongs to S. Mod of z plus half is greater than equal to half belongs to S. And fourth one is set S has exactly 4 elements. Are you stuck somewhere?
No, sir. I think I've almost got it. Just a second. Sir, I'm getting option 2 is correct.
Hmm, that is correct. Okay. See, from here, what can we say? Mod of this is 1.
Yes, sir.
So if you like directly the complex number, it will be some 1 into e power I theta, right?
Yeah.
The complex number can be written as this so that the mod will be 1, right?
Hmm.
Now you can just solve it like a quadratic and get a condition. This is a quadratic on z. So if
Yeah.
you want, you can just solve it like a quadratic and set z is equal to -1 plus minus root over 4 b square 1 minus 4 times this. So 1 minus 4 plus 4. So
So
4
4 EI E
theta
power.
minus 3 by 2,
Oh.
right? So you can see there is a -1 by 2 here.
Hmm.
The minus 3 by 2. So you can get z plus half is equal to plus minus this thing, right?
Yes, sir.
So let's calculate that. We have z plus half is equal to plus minus root over 4 ei theta minus 3. Now this can be written as 4 cos theta minus 3 plus I into 4 sin theta square root of this.
Yes, sir.
Okay. Now we need to find out the mod of this, correct?
Yes, sir.
So, okay, so we need the mod of this. So we'll have to figure out a way to express this properly. So mod of this will be equal to without the plus minus mod of this, right?
Hmm.
So if I square it, what will happen? If I square the mods, I would get what? Mod of z plus half squared is equal to mod of 4 cos theta minus 3 plus I into 4 sin theta, right?
Yes, sir.
And the mod of this complex number will be square root of 4 cos theta minus 3 whole square plus 16 sine square theta, and that is equal to square root of 16 minus plus 9 minus 24 cos theta, right?
Right.
Square root of 25 minus 24 cos theta is mod of z plus half whole square, correct? And is there, do we know any theta range? Okay, so theta is between minus pi to pi for sure.
Hmm.
So basically, we know that the minimum value of theta is minus 1 and the maximum value of theta is plus 1, right?
So,
So when you do minimum value, you will get 49 here, correct?
right,
And when you do maximum value, you will get 1, right?
right.
So the range of this expression is 7 to 1, right?
Huh, right.
So z plus half whole square is between 1 and 7.
Yes.
So we are getting 1 to root 7 for mod z plus half, right?
Hmm.
1 to root 7. And now we can say that it is clearly greater than half, right?
Greater than half.
So that is done. That part is done. Uh,
Yes.
Option D is about set S has exactly 4 elements, but set S was the set of solutions of that equation, right?
Yeah.
You had two different solutions. See, from here, it was the solutions of the equation without the mod, right?
Hmm. Hmm.
It was this equation only, but without the mods and all.
Yes.
So there are two solutions. No, it cannot be like 4 solutions, right?
Yes.
You can take the square root of a complex number. It's not impossible. But after that, you only have plus minus options.
Right.
You understand?
Yes, sir. Sir, I tried doing it in a different way.
Hmm.
I use the triangle inequality instead on z square plus z plus 1.
Hmm.
So I open it as like mod z square plus mod of z plus 1 will be greater than or equal to mod z square plus z plus 1, right? So, and
Mod
that we
z
will,
square. So we can say it like this.
yes, sir.
Okay. Right.
Sir, it will be mod of z plus 1 uh, whole mod. Like, um, I took z square and z plus 1 as my two complex numbers for the inequality.
Okay.
Yeah. And we know z square plus z plus 1 whole mod is 1. So we get that, and then we can just open both the mods here. And I got like x square plus x plus y square is greater than equal to 0. So we get like a circle, but the complete
1 second.
outside.
Uh, this property is true, right? I think so, right? This
Yes,
is
sir.
true.
Yeah,
So we can write this as z square plus mod of z plus 1.
yeah.
Then what are you saying?
So then we can just open the mod and we'll get like in terms of x and y, and we get like a circle equation, but we
What do
get
you mean open the mod? How?
like x square plus y square, take z as x plus iy.
Okay.
Yes, sir. And we get x square plus y square plus x square plus 1 plus
This is what you're getting, right?
yes. Oh, 1 second, sir. I think
You
I made
made a mistake here.
yeah. Right. Yes.
Okay, fine. We'll go ahead. You understood how we have done it, right?
Yeah. Yes, sir.
Okay. Again, this question is saying S is set of complex numbers Z which satisfies Z minus 2 plus I is greater than equal to root 5 if Z naught is such that 1 by mod of Z naught minus 1 is the maximum of the set 1 by mod of Z minus 1 such that Z belongs to S. Then the principal argument of 4 minus Z naught conjugate divided by Z naught minus Z naught conjugate plus 2I is what? You should think a little bit geometrically here. That will be better.
Yes, sir.
Maximum value of this set would be, if you want to get maximum value of this number, you need to get minimum value of
All of
this.
them. Yes, sir.
Minimum value of this. Wherever that is your Z naught.
Right. Sir, minus 5 by 2.
Hmm. That's correct. Minus pi by 2 is the answer. You have to be careful because principal value of the argument is from minus pi to plus pi.
5.
You cannot say 3 pi by 2 or something.
Yeah, right.
Or, yeah. So, also, this is like if you think this is the exterior of a circle,
Yeah.
and when you're seeing this points on that exterior of the circle, after that, you have to think of this as the distance of a point z from the point 1 comma 0.
Yes, sir.
So then you have to think of the common region where this can happen. So it will come by doing perpendicular from the center to the line where 1 comma 0, right?
Hmm.
Do you understand what I'm saying?
Yes, sir.
Circle center is at 2 comma minus 1,
Yeah.
and circle's radius is given as root 5. You have to be outside this circle.
Yeah.
Z lies outside this circle.
Yeah.
Now, you also have to minimize the value of mod of z minus 1,
Hmm.
right? So, the one point is where? 1 comma 0, right? So, it will
Hmm.
be somewhere here, correct?
Yes, sir.
This is my x-axis. And notice that the circle, I think, passes through the origin.
Yeah.
So, this is a point on the circle,
Yes, sir.
uh,
0.
0 comma 0. This is the point 1 comma 0. And I have to find points outside which are outside this region, which are minimizing the value of mod of z minus 1.
Hmm.
So what was your point that you found?
Sir, 0 comma 0 or well, it can lie on the circle as well, right? So 0 comma 0 was one of them.
This is 1 unit,
Yeah.
uh, but any point on the circle, is there a point which is at a smaller distance than 1, right?
I didn't find any.
Uh, so basically, this is a radius root 5,
Hmm.
and so let's say that point z naught is some x plus iy.
Yes, sir.
Mm, this is your z naught. From here, it looks like it should lie on this line. No,
Right.
the minimum distance will be like this, I think, not this. So if you think about it, if it lies on this line, the line slope we can get, no.
Right.
So we will get 1 by minus 1. Minus 1 is the slope of the line,
Hmm.
right?
Yes, sir.
And it is a line equation passing through 1 comma 0 with slope minus 1. So then we can find it where it intersects the circle,
Yeah.
correct?
Right.
So line equation you will get, circle equation you can write in Cartesian coordinates, and then you can get z naught.
Hmm.
Ultimately, the question is not about finding Z0, it's to use Z0 to find the argument of the final complex number.
Yes, sir.
But I think the minimum distance from 1 comma 0 would be like this along the center,
Yes, sir.
because otherwise though it is more distance, no?
Hmm.
This is the shortest path from center to this.
Yes,
So
sir.
if this point lies on a radius, then that will be short, I think.
Right.
So after that it is doable. Finding this point is not difficult because you can get the line segment equation. This y minus 0 is equal to minus 1 x minus 1, right?
Right.
Y is equal to 1 minus x. You can put that in the circle equation. Circle equation is x minus 2 whole square plus y plus 1 whole square is equal to 5,
Yes.
right? So y is equal to 1 minus x. If I put, I'm getting x minus 2 whole square plus 2 minus x whole square is equal to 5. So I'm getting 2 times of x minus 2 whole square, right?
Yeah.
So x minus 2 is coming as plus minus root over 5 by root over 2.
Uh,
So it is clear that the x coordinate here is negative, or it could be plus also. Actually, it is not negative right now from the figure.
hmm.
So we can get, oh, but it cannot be 2 plus, right? 2
Yes,
plus
sir.
will put it this side of the center, right?
Right.
So you have to be x is equal to 2 minus root
Fine.
5 by root 2, right?
Yes, sir.
And y would be 1 minus x, so 1 minus 2, so root 5
One.
by root 2 minus 1.
Yeah.
So these are the points that gives us our z naught. And after that, finding the argument should not be difficult because it's a simple type of situation. You have to do z naught plus z naught conjugate once and z naught minus z naught conjugate plus 2i,
Hmm. Right.
right? So,
Yes, sir.
so be careful. This was slightly more complicated because the locus was a little weird. Uh, but most of the questions you are able to do. These are all the last. This one was JEE 2019. The questions before that were all the more recent ones.
Yes, sir.
So the main thing you have to take away is that you are able to solve JEE paper questions on complex numbers, and also this is one of the chapters that you have to try. In
Yes,
the
sir.
exam, the main thing is to not get scared of the paper. Main thing is to have confidence and realize that you can always find 10, 12 good questions to attempt. If you are able to find 10, 12 decent questions, then you will be able to score a good percentage marks.
Yes, sir.
So don't try to attempt too many, but you have to have faith that your prep is good enough to do 10 to 12 questions in a 1 hour.
Yes, sir.
So far, what we are seeing is that you are able to solve. So complex numbers also you're able to do. So that is good. So make sure that you have that confidence in the exam and don't go with any preconceived notions. By preconceived notions, I mean don't expect that this chapter has to be easy or this chapter has to be hard.
Right.
Sometimes the more you have such ideas in your head, the more you will be shocked by the paper.
Yes, sir.
You don't want the paper to shock you. You want to be like, okay, whatever comes, I will deal with it as and when the situation arises, right?
Right.
If you go with preconceived notions, you can get shocked and then you'll panic in the paper. What is that is the last thing that has to happen. You have to avoid that. It
Yes, sir.
could be that they will give many questions on easy chapters which are difficult. Questions
Hmm.
can be made on whichever chapter and it might be difficult. But you have to mentally be like, I will see the questions and I will give them a try and I will look for the ones that I prefer.
Yes, sir.
And I will look through the entire paper for sure and not miss out on some easy question.
Hmm.
And just because a question looks difficult and is big and scary looking doesn't mean it is hard.
Right.
You should have seen the last few years papers, especially in physics and all. You will realize that many times they give very long, long paragraphs and all,
Yeah.
right? But when you actually see the solution, you will see that they will be based on simple 2, 3 concepts and that's it.
Hmm.
So the point that you need to remember is that the more they keep talking about and more things they have to mention in a problem, the it is more likely that the solution is going to be super simple.
Yes, sir.
So many conditions if they have to impose on a question, and so many things if they have to mention, it is likely that the solution will be simple based on 1 or 2 ideas.
Yes, sir.
It is many times it has been seen that it is harder when they have a simple problem statement, the question is super hard.
Hmm.
So one thing to note for sure is that do not get scared by the way the question looks. The way the question looks has nothing to do with its difficulty level. Okay.
Okay, sir.
Whatever it is, you have to read it once or twice before deciding whether you leave it or whether you do it.
Right.
Every question in the advanced paper, you have to read it at least once or twice. Then
Right.
only you can make a proper judgment. And this exam is not about minimizing negatives and so on. Do you understand what I'm saying?
Yes, sir.
It's not at all about time and speed and stuff.
Hmm.
Because ultimately there are only 17, 18 questions in one section in 1 hour, right?
Yes, sir.
And you are if you get 10 out of 18 in all 3 sections, you will get a good rank in JEE.
Yes, sir.
So 50% above score is a very good score for JEE Advanced. So the point is that you have 5 to 6 minutes per question, which is enough time to solve.
Hmm.
The main thing is to not worry about negatives so much, but to look for easy opportunities or look for things that you can do. Even if it is the part mark of a multiple correct, you should try it out.
Yes, sir.
Because even if you get one option, you get 1 or 2 marks, right?
Yeah.
So every question has to be read, every question has to be thought about. You should think about it for 1 minute at least, and then decide whether to go ahead or skip.
Yes, sir.
And don't go with preconceived notions about this type of question will always be difficult. Multiple correct has to be difficult. Numerical has to be easy. Such things are not true always. Just because a question has no negative mark doesn't mean you have to attempt that.
Yes, sir.
You understand what I'm saying?
Yes, sir.
Some people have that thing that there are 8 numericals, none of them have negative mark. I have to attempt all of them.
Hmm.
Such things are not necessary. There might be some multiple choice questions which are easier, which you have skipped just because you felt like negative marking is not there in numericals.
Yes, sir.
So, no preconceived notions and full faith in your own ability. You are well prepared. You are well prepared to score 10 to 12 marks in the 10 to 12 questions in the paper. That much your preparation is good enough to do. Maybe you are not well prepared to score 14 out of 15, 14, 15, but 10 questions you can definitely do right now. Do you understand what I'm saying?
Yes, sir.
It's all about not panicking on the day of the exam, managing your time in a nice way, and seeing whatever the paper shows you, you have to deal with it then in a relaxed manner and find the 10 questions.
Hmm.
So keep that in mind. Uh, Next class and all will be physics, I think. You
Yes, sir.
continue. Okay, fine.
Thank you, sir.
Hmm.